Okay, welcome to my presentation. I will show what I've done or what we've done in our paper, Javalin Throw analysis and assessment using body-worn sensors. And yeah, we wrote this together with Sebastian, Fenn, Stefan, Göbel here as well, and myself. First off, why would you actually want to do this? The goal was to recognize and analyze Javelin throw. And the problem for many athletes is the coach is not always available, especially during the COVID time, but also now you don't always have a coach, and if you want to practice alone on the field, you don't have somebody who can give you objective feedback from an outside perspective. And for movements like these, as you can probably imagine, it's very difficult to see like a small performance mistakes. Maybe I should stand here, sorry. It can be very difficult to see small performance mistakes when actually doing these movements. So it is helpful if you can get some outside perspective. That's not just a coach, but ideally some app you can take with you to the field when you practice that gives you some feedback on what you can improve. And the difficulty here is also that the movement is performed at a very high speed, especially the throwing motion is at a very high speed, which can actually make it difficult even for coaches to notice some mistakes in real time. So yeah, that's why we thought about why can't we use sensors to detect these motions. And ultimately we want to use this for a tool which can support both athletes and coaches during the practice. And in a later step, that we won't cover here, the idea is to also integrate some additional gamification aspects, so you have an application that covers both the assessment part as well as the motivational part that some athletes may need, some may not. Okay, and yeah, for this purpose we decided to use body-worn IMUs. There are many sports analysis systems that rely purely on camera data, and we thought about whether that makes sense and yeah, what could be some advantages of body-worn sensors instead. If you think about camera systems, one big issue is always you need a stationary setup, especially if you want an outside perspective, which you would want in this case. So if you're on the field with like multiple people, you would have to take care that the system is always in the right place where you can actually practice, and if you have different lanes you would have to adjust that, and you can also have problems with like the recording rate because you need to be very high speed and you need a high resolution if you want to cover the complete motion with the run-up. So the resolution for the individual parts of the motion can be small in the end. But ultimately the main reason was, yeah, it's very stationary, and also not necessarily everybody has like a high resolution, high speed camera and some position where you can actually place it during the training to get a good recording. And there's also some other problems that can occur, for example with occlusion. When you do the hip movement you actually do a rotation at the end of the throwing movement, and some parts of the body may be occluded and not be on the camera, so you might even need multiple cameras to get a proper analysis in this case. So that's why we decided to use body-worn sensors, and we really decided to use IMUs, which are included in all sorts of commercial devices like smartphones, and also in most fitness trackers, activity trackers, smartwatches, etc. So while we decided to use these boards that we built ourselves, there are also commercial boards you can use and fit in like a sweatband as shown on the right side, but you could also just use a fitness tracker. We also tested this earlier. It's basically the same data, it's just that these are cheaper. And yeah, our approach was to first analyze the throwing motion. So basically all the different steps of the motion. There's also a run-up that we haven't shown here, and a step before that we also include in our analysis. But these are the most important steps, and yeah, from the left to the right, these are the things we focus on. So first you have the impulse step before you actually start the throwing motion, which is basically the last step here with the right leg. Then the hip application, this is where you want to start rotating. And here it shows the hip application in one area, but basically the hip application is during the whole movement from that point on. Then you have the bracing step. I think I'll go a bit quicker over this part. If you want some details, you can read it in the paper. But yeah, basically the bracing step is still important, which is basically on the other leg, the last step. And then you have the start of the arm movement where you actually throw your javelin and then the actual throw. And the last part after the throw is something that's not really worth analyzing because most athletes just do whatever helps them to stop the movement in a, yeah, how they like it. There's no specific way, at least that we found in like training literature, that says how you need to end or should end the motion. So basically, this whole analysis is based on like different training literature we look through, and also we discussed with different coaches in Germany that are licensed, and including one that's a coach of a national team as well. So we're pretty confident that at least we got the basics down. Also my colleague himself does Javalin Throw, so it's not like we have no idea at all. And yeah, here you can see the positioning. We decided to use 4 sensors in the most important spots. We checked a few different spots, but ultimately, as you can imagine from the previous slide, we definitely want sensors at both legs, and at both legs, and we also want a sensor at the arm that's actually throwing. That's important. We also had a sensor earlier at the other arm, but we decided that's not really necessary. We didn't get any really useful data from it. But a sensor at the hip is very important to get the hip movement and decide whether the whole hip rotation is actually enough, because you want at least a certain rotation during the whole motion. So here's some data for people who like to look at like raw sensor data and just decide to throw this in. It's not quite the raw data, it's also it's already a bit pre-processed. So in this you already see it a bit flattened, and you also only see for the different sensors, like each line is a different sensor at one of the positions, and it's the total acceleration at the sensor. It's not each axis. Like usually when you have the raw data, you have the 3 axes, and in this plot you only see one metric that's basically the total acceleration. Otherwise it would have been even harder to see anything here. But what's important is these vertical lines, as you can see, are basically the most important points that our system detected, that are the different points in the motion sequence. And especially here, where the blue line peaks, that's where the hand has the peak in its acceleration. And we have a few different methods to make sure that we actually get the throw. Like this is supposed to be the throw, in this case it's also the throw. And from our analysis we can very accurately get the point of the throw. And this is basically our frame of reference. Based on this point, we then decide whether, first off, in which area, here and here, in which area we actually look for relevant peaks of the other sensors. And we also decide, okay, this is the throw, and then we look at the other sensors and look at, okay, this is the last step on the left foot, etc. So this is basically where we decide, where we start our analysis. But yeah, more details in the paper. And here I also only want to go quickly over it. You don't have to look at all of this. This is basically how we generate our feedback in our application, where we just go through. First we check if there's actually a feasible analysis, and if we don't accurately, or we're not certain that we get the point where you actually throw the javelin accurately, then from the very start we say, okay, we don't think we can accurately assess this. And usually that's only the case if the whole movement was done very incorrectly, or the javelin's never thrown. Obviously it's possible that somebody just runs with the javelin. Only happens with beginners, at least in our evaluation, but it happens. And then basically we go through the different steps that are already explained. We basically check, okay, is there a hip application? Like, do you actually start rotating your body? If not, then you generally cannot generate enough force to get a very good throw. And we also check, okay, is it at the right moment with these two steps, before the impulse step and before the stemming step. And yeah, basically what I've already described on the previous slide. And depending on which of these factors are incorrect, we then generate feedback that we can give to the athletes. And yeah, if all checks are correct, obviously the feedback is, yeah, the whole motion sequence was correct. And this, you can actually see it somewhat well. This is an example of an evaluation sheet we generated during our evaluation. We also have an application nowadays, but we didn't have it at that point. And yeah, this is basically the feedback we gave to the athletes, to get feedback from them. Okay, is this appropriate? Is this, like, do they feel this is correct? Obviously they can't necessarily say is this correct, because they don't really notice it themselves. That's why we also included coaches. But this is basically the feedback we generate. We show the important steps when they happened, the time differences, and we also, in this case, you may wonder why are there pictures? I was talking about body-worn sensors. This is just for our evaluation. This is not for our application. These images are not used in the analysis. They're only used for the feedback in this case. So we could further discuss with the coaches if the feedback was actually correct. And in this case, okay, everything was correct. But if it wasn't, then you would have some text here on which parts were incorrect. And also what you can see here, we also include like the acceleration when you actually throw, so you can compare between different throws. What we didn't include on purpose is something like an estimated distance, because we can't get the angle properly, and even the velocity, since we only get the acceleration, isn't quite accurate usually if you calculate it. So, okay, for our evaluation. You may wonder, you have level 1 to level 4 here. These are basically the different performance levels for the athletes we invited. And level 1 are complete beginners, and we have relatively few of them, only 4. And level 2 and level 3 are like intermediate athletes, sometimes athletes which not only do javelin throw, but do like, Zehnkampf, I'm not sure what's the English word for it, but yeah, like other disciplines that also include javelin throw, so it's not completely their focus. And then you also have the 4th category. These are basically professional or at least semi-professional athletes that focus on the javelin throw. And yeah, you can also see on the left side we have different conditions that we tested the system on. Sadly, we couldn't get all levels of performance in all different conditions, because we were basically limited to where these athletes were training. Because we also invited coaches to get live feedback to compare it to our system, which means, yeah, most coaches aren't into, yeah, come at this time to this point, and yeah, we basically have to go where they are, not the other way around. So in total we got 31 athletes with their respective professional coaches, or at least licensed coaches. And the procedure was pretty much, we gave the athletes the sensors to wear. We instructed them roughly how to wear them, but we didn't like put them on the athletes, because we want to make sure they can actually use it themselves. Like, if you need assistance every time, then our system isn't really useful. And while they were applying the sensors, we talked to the coaches and basically told them, okay, give us the feedback you would also give the athlete. These are the things that we try to determine if it's done correctly or not. And these are also the things we previously discussed with the coaches. So our system was already designed together with the coaches. So these aspects aren't something we dictated them, but it's basically the same aspects we typically check as well. and then we told them to both tell us so we can record it and also write down any feedback they would give to the athletes so we can compare it to our analysis later. And yeah, then the athletes basically did their training as usual, and each of these athletes did multiple throws. Usually we recorded around 10 to 20 throws per person, and we generated feedback, the coach gave feedback, and we later compared it. And if our system said there is a mistake, and the coaches didn't say there was a mistake, to make sure what's right, we had the video recording, which we went through with the coach. So if the coach said, okay, he was right, then we assumed he was right. So all the evaluation results we present is basically worst case scenario, because it could also be that the coach was wrong, even in the post-analysis. So what are our results? Here you can see for the 4 different performance classes, like on the left side, for the 4 different performance classes and also for the different weather conditions. And in each of these plots, the left side is our system performance, basically how many throws were correctly assessed, had completely correct feedback. Like our standard for a correct assessment means the feedback is complete and correct. So if only one of multiple mistakes was found, that was also classified as incorrect. And on the right side, respectively, in dark is always the coach's performance. And as you can see here, and the better performance classes, like the professional athletes in 4 and the semi-professional or amateur athletes in 3, our system actually outperformed the professional coaches. So in these cases, our system was able to find some mistakes that athletes did that we later went through with the coach, and the coach said, okay, this was an actual mistake that I did not find. And in these cases, for the weaker classes, like the beginners, and like the, maybe a bit better than beginners, but still not that great amateurs, but they still know the rough movement of the javelin throw. And for these, the system performed worse than the coaches. It's basically down to some of these mistakes were so large, especially for the very beginners, that our system didn't include them because they didn't really do the javelin throw motion. Like the example before, when you just run through, our system cannot assess that properly because we don't know when you are supposed to throw the spear. So yeah, that's why in general our system works better for better athletes. And here I don't think I want to focus on these parts because this is mostly dictated by which athletes actually were active in these conditions. But yeah, it's pretty similar. And here we can see in how many cases our system actually outperformed the coach. And as you can see, it's not quite comparable to the previous slide because okay, I forgot the part. But okay, basically in these cases you got some feedback from the system that the coach did not also find. So in these cases the system would have been helpful even if the coach was also present. So you could use the system even to assist the coach, not just the athletes themselves, to get some additional feedback. Obviously the coach should still look over it, especially in these cases where only very few cases the system was actually better than the coach. I think I skipped this. And for the conclusion and the outlook, our contribution is a sensor-based Javalin Throw assessment system. It's completely mobile. It consists only of wearables, and the calculations are done on a smartphone in real time, or semi-real time, shortly after the throw. And we have a comparable performance to a licensed coach, and can effectively assist both athletes and trainers. Although for beginner athletes we would highly advise to still have a coach present, or at least have some video footage they can also look through, because in many cases like there are so rough errors that our system cannot really assess the whole motion properly. And for our outlook, first off, we could try to optimize our system a bit so it better works for beginners. So maybe check different conditions that are typical for beginners. Yeah, we could try it maybe. We could improve the application. We have already done this, make it better usable, add some gamification elements, and yeah, for the analysis, we could also look into the throw distance, but we would have to somehow measure this. And yeah, another aspect that we are actually in process of is to adapt it to different sports, such as shot put, wide jump, high jump, discus throw. Also some thinkable, but these are the ones we are already looking into right now. So, yeah, the sources, okay. Thanks for listening. Are there any questions? I think the time is over anyway, but thank you.
Philipp and Sebastian, I think if the next speaker could come down.
He's already here.
Oh, you're there. Oh, no, you're Sebastian. My apologies. Okay, great. So Robert Conrad, so you're presenting from the same laptop?
Yes.
Okay.